Right, here are the solutions for week 4, lesson 9 in unit 7. For the first one, we want to find all solutions to each equation. So using our zero product property in this first one, if we're multiplying two things here, in this case, we're multiplying that x times x minus 1. One of them has to be 0 in order for me to end up with 0 as a product. So this is kind of easy. The first one, just set it equal to 0. So that makes this factor 0. But the thing that makes this factor 0 is going to be x equal to 1. And we can set that equal to 0 and show by solving this equation that we do get x equal to 1. So our two values for x are x equal to 0 or x equal to 1 for this first one. On the second one, I'd have 5 minus x equal to 0. We can kind of tell that that's going to be x is equal to 5, but just to go through the equation solving here, for this one I would add x to both sides, so then you don't have to worry about a negative x there. So you get 5 is equal to x, which is the same as x equal to 5. And then the next one, 5 plus x is equal to 0. If we set that equal to 0, we can see that we would need to subtract 5 from both sides, and we get x is equal to negative 5. So those are the two solutions for that for B, I mean. For C, we're going to have a little bit more work with solving for x in this first one. We have 2x plus 1, and we want to set that equal to 0. It's not always as obvious as it was in those first two. So then you'll want to do this equation solving to get the exact answer here. So if I subtract 1 from both sides, and then my next step would be to get x alone by dividing by 2, I would have x is equal to negative 1/2. So that's the value that would make that first binomial 0. The second binomial, though, is pretty evident just by inspection. We have x plus 8 is equal to 0. So we would subtract 8 from both sides, and we get x is equal to negative 8 then. So x equal to negative 1/2 or x equal to 8, either one of those values for x would end up with 0 as your product. In the next one, letter D, these two are identical. They're the same, so we only have to do it once, which means this one only has one x value that's going to make it 0. And if we add 3 to both sides, we get 3x is equal to 3. So divide by 3 on both sides, we'd have x is equal to 1. And that's it. We don't have to do it again because the other one is the same thing. So x equal to 1, this must be a parabola that just sits on the x-axis right there where x is equal to 1. So one solution, whereas the other ones go through the x-axis twice. Letter E, we'd have 7 minus x is equal to 0. So add x to both sides, and we'd have 7 is equal to x. So x is equal to 7 goes here. And then if we do x plus 4, set that equal to 0, we would subtract 4 from both sides, and we get x is equal to negative 4. So those are our two values for the final one there for letter E. Either of those values for x would make that a true statement because you'd get 0 in one of those places. And when you multiply two things, our zero product property tells us if one of them is 0, your result is 0, or your product is 0. So rewrite each equation in factored form and solve using the zero product property. Now we're going to come up with the factored form from this standard form. So it helps to kind of use a chart or a diagram to help you keep track. We'll multiply and then add factors and see which ones work. So in this case, we always want to multiply to get that last term and add to get this coefficient on the linear term there. So what two numbers, let's see, multiply to give you a positive 6? Well, we would have positive 1 and positive 6, and when I add them, I get a positive 7. Close, but not quite. But if I change those to both negative numbers, I'd have negative 1 times negative 6. That still gives me a positive 6, but when I add them, I get negative 7. And so those are the two that I want. I want x minus 1 times x minus 6. And that tells me that x has to equal 1 or 6. Either one of those values, because if I put x minus 1 is equal to 0, I'd add 1 to both sides, and I would get x equal to 1. And if I do the other, x minus 6 is equal to 0, I would add 6 to both sides, and I would get x equal to 6. So here it is in factored form, and here are my solutions for 2a. 2b, I'm going to do the same process, but I'm going to look for numbers that when I multiply, I get 81, and when I add, I get 18. And it looks like they're all both positive, and so I don't need to worry about negative values, negative factors this time. So 1 and 81 gives me 82 when I add them. 2 doesn't go in there. 3 goes in there 27 times. And when I add 3 and 27, I get 30. That's too much. The only other factors of 81, 4 doesn't go in there, 5 doesn't, 6, 7, 8. None of those go in there evenly, but 9 times 9 gives you 81, and when you add, you get 18. So I'm going to have x plus 9 times x plus 9 equals 0, and this one, just like the one above, has two identical factors, so I only need to find out what this is equal to, and then I've got my one solution. So x is equal to negative 9 is the solution for that one. And then, let's see, the next one, I'm going to be looking for two numbers that when I multiply, I get negative 60, and when I add, I get 7. So I'm going to try negative 1 and 60. That gives me 59 when I add them. If I do positive 1 and negative 60, that just gives me a negative 59. If I go with 2 and 30, I could make that negative. That gives me a negative 28 when I add them. Negative 2 and positive 30 would give me a positive 28. Let's go with 3 and negative 10. That will give me a 20. I need to get a 20 here. 3 and 20, sorry. Negative 20. When I add them, I'll get negative 17. If I go negative 3 and positive 20, I get positive 17 when I add. 4 goes into 60 15 times. 60 has a bunch of factors. So if I do 4 and negative 15, I would get negative 11 when I add. And if I do a negative 4 and a positive 15, I'll get positive 11. Still not 7. 5 goes into 60 12 times. So I'll do 5 and negative 12. And that will work. Close, but it gives me a negative 7. So I'm going to want to use negative 5 and positive 12 because then that will give me a positive 7 when I add. So finally, I have it. X, I guess we're using u now instead of x. So it's u minus 5 times u plus 12 is equal to 0. I guess this should have been d up here also. So these would have been d's. Sorry about that. Did I just... Okay. So, so solving these, let's see, let's get rid of some of this so I can have room to solve these now for u, the u values that will give me 0 when I multiply one of those factors times the other. I have u minus 5 is equal to 0, and so I add 5 to both sides. And that gives me u is equal to 5, so that's one solution. And the other solution, I would have u plus 12 is equal to 0. And so I would subtract 12 from both sides, and I get u is equal to negative 12. So u is equal to negative 12 goes there. And the last one here is another x variable, and let's see. I want to multiply to get 0.01, and I want to add to get 0.2. This is a tough one to try and think. I guess I put those up here, didn't I? But it kind of, if you go backwards, if you think about what adds to give you 0.2, 0.1 times 0.1 gives you 0.2. And when you multiply those two, you do get 0.01. So this would be x plus 0.1 times x plus 0.1. So it's one solution, and it's going to be, if we set that equal to 0, we're going to have to subtract 0.1 from both sides. So we get x is equal to negative 0.1. So let's see, we'd have x equals negative 0.1 for that one. Number 3, here's how Elena solves the quadratic equation x squared minus 3x minus 18 is equal to 0. Is her work correct? And if you think there's an error, explain the error and correct it. Otherwise, check her solutions by substituting them and show that the equation remains true. So I was looking at this a little bit earlier. I think she made a mistake. Let me see if I can explain the error. But so right here, this factors, let's see, when she does if she made her chart and she multiplied on this side and added the two factors together on this side, we want to multiply and get negative 18 and add and get negative 3. So it looks like she chose negative 3 and 6. So negative 3 and positive 6, but when you add those two, you get a positive 3. So she should have used this combo, 3 and negative 6, because then when you add them, you get negative 3. So it should be x plus 3 times x minus 6 then, equal to 0. And then when she solves these, x plus 3 equals 0. You would subtract 3 from both sides, and you get x minus 3. X equals negative 3, I mean. And if you solve this, x minus 6 is equal to 0. You would add 6 to both sides, and you get x is equal to a positive 6. So this should be x equals positive 6, and this should be x equals negative 3. And so this is where she went wrong, right in there. All right, number 4. Jada is working on solving a quadratic equation as shown here. And she thinks that her solution is correct because substituting 5 for p in the original expression gives 0. 25 minus 25. She's correct, but she made a mistake because she forgot to set this factor equal to 0. So p could be 0 also. That would also give you 0 when you multiply. So p equals 0 or p equals 5. Number 5, choose a statement to correctly describe the zero product property. So if a and b are two numbers and a times b equals 0, then both a and b must equal 0. No, that's not true. Neither a nor b can equal 0. No, that's not true. But either a or b is equal to 0. One of those two has to be 0, and not a plus b either. Number 6, which expression is equivalent to x squared minus 7x plus 12? So we're going to factor this, and we don't have to solve it, just factor it. So we want to multiply on this side and add over here. So we're going to multiply to get positive 12, and when we add, we're going to get negative 7. I'm going to go with the 3 and 4 here. It looks like negative 3 times negative 4 would give me a positive 12 when I add, or multiply, and then when I add, I'd get negative 7. So I'm going to choose that one. And that's it for this week's homework. I hope this helped. Please stop into office hours if you need more help.